Dear students, today we will explain a type of flow in which there is a uniform flow as well as there is a sink. So it is a combination of two types of flow, so uniform flow and source at origin. This is just assumption. You may take source at some point also. So in this part we will take source at origin, and there will be naturally some strength of the source. Let the strength be M. Now in this flow problem, first of all we are saying that there is a uniform flow. It simply means that fluid is flowing either in x direction or in y direction. Suppose it is flowing in x direction. Suppose uniform flow is in x direction. So it means you may write that the horizontal component of velocity will be equal to some u. That is, fluid is flowing in x direction with some velocity, some constant, because it is a uniform flow, some constant velocity, say capital U. So we may write U is equal to U. Now if I assume U to be minus delta phi delta x, V to be minus delta phi delta y, then you keep remember that W will be, rather dW dz will be minus U plus IV. If you take it to be in terms of positive, its expression will be changed. So if I take U is equal to U, then delta phi delta x is equal to U implies minus phi is equal to ux plus some constant of integration, and we assume it to be 0. Now similarly we have a relation delta phi delta x is equal to delta psi delta y. So using 2, in place of delta phi delta x I may put minus u is delta psi delta y implies psi is equal to minus uy plus some constant of integration, and again that will be 0. Now combining 2 and 3, I may write the complex potential. You are studying the flow problems with the help of complex potential technique. So what is the first step of complex potential technique? That first of all you find phi, you find psi, and with the help of those phi and psi we create the complex potential function. As in this case we are considering this first part. This is the uniform flow and together with the source of strength M at origin. So in first part I have found phi is equal to minus ux. I have found psi is equal to minus uy given by 3. So by combining 2 and 3 I may get from 2 and 3 I may get w is equal to, I say it w1, phi plus I psi. So it is equal to phi is minus ux minus iuy, because psi is minus uy and minus u is common, x plus iy is equal to minus uz. It simply means that the complex potential for a uniform flow is minus uz. Assume it as 4. Now we come to second part. In second part we also have a source at origin. So what we do? We know that since there is a source at origin of strength M, since you have taken u and v in terms of minus delta phi delta x and minus delta phi delta y, so your W2, that means complex potential function for this situation, will be minus m log z. This is the formula which we have derived earlier, and so its number will be 5. In fourth, you have derived W1 for the uniform flow, and in fifth, you have derived W2 for a source at origin of strength M. And as we know that in our flow problem, there is a uniform flow as well as a source. So method of superposition is applicable. Finally, for uniform flow with source at origin of strength M. 4 and 5 say that what is W? W is equal to W1 plus W2. So in this way, whenever you have a situation in which there are more than one type of flow, more than one types of flow, like there is uniform flow, there is a sink, there is a source, there is a doublet, or there is any other combination of the fluid flows, then for different types of flow, like for source, for sink, for uniform flow, you derive different complex potentials. Just add them, you will get the complex potential for the combined situation. So likewise we have done here. It is minus uz minus m log z. This is W. We may write it in Cartesian coordinate, we may write it in polar coordinates. So W is equal to phi plus I psi minus u x plus iy minus m log z x plus iy. Again you write x plus iy. Open it, minus ux minus iuy minus m, and formula for log x plus iy is 1 upon 2 log x square plus y square plus I tan inverse phi. This is the way to write log x plus iy in terms of real and imaginary parts. So comparing phi is equal to minus ux minus m by 2 log x square plus y square, and psi is equal to minus uy minus m tan inverse y upon x. Usually in such type of problems, when we describe the flow, we concentrate on the streamlines unless and until the potential lines are asked. So we will concentrate on streamlines. We know that streamlines are given by psi is equal to constant. So take minus uy minus m tan inverse y upon x is equal to constant, or take this constant to be 0. This implies tan inverse y upon x is equal to uy upon m with minus symbol, or x y upon x is equal to tan of y upon x is equal to tan minus uy upon m, which is minus tan uy upon m. Again solving, you may get x or you may get an expression in terms of y. Now we come to the situation that we cannot recognize this curve easily. You know that y upon x is equal to minus 10 uy upon m is not recognizable. You may draw it, but as such you may not say that what is its shape, what is the shape of streamlines. So how we draw the streamlines in such situations? We take just a minute, wait for a minute. Now we try to draw these streamlines. For that, first of all, we will take the stagnation point because that is again important. So for stagnation point, what we do, we use this expression. We use this expression A. A implies delta W delta Z is equal to 0 because it is the condition for a stagnation point when minus U minus M upon Z is 0 or when Z is equal to minus M upon U. You may write Z as x plus Iy is minus M upon U. This implies at the stagnation point x is minus M upon U and y is 0. Or you may say that stagnation point exists when, or you may say at, एक साथ लिख देते हैं इसको, at minus m upon u and 0. Now it will be helpful in drawing the streamlines. So these are stagnation points. Now you know the stagnation point, you know that there is a uniform flow, you know that there is a source at origin. So we will try to draw it. देखिए कैसे ड्रॉ करते हैं. इस पर ड्रॉ नहीं होता है अच्छे से. This is your origin. Okay. So from this origin you are getting the streamlines. We know that streamlines emerge out radially. So streamline will go in this direction, streamline will go in this direction, streamline will go in this direction. इस तरह से ये streamlines बनेंगे. ये हमने कुछ streamlines बनाई हैं. अब हमारी streamline ऊपर भी जाएगी, इधर भी जाएगी, इधर भी जाएगी, सब तरफ जाएगी because यहाँ से सब emerge हो रहा है fluid. But we are getting a stagnation point. This is the stagnation point. This stagnation point is given by minus m upon u and 0. It simply means that whatever streamline is coming from here will come to rest here because here the velocity is 0. So this is the streamline. And now this is streamline, and similarly there is a uniform flow. So this is a uniform flow with velocity u. This streamline will come to this point, it will stop, and due to this uniform flow it will go like this. इधर तो ये एरो है और ये यहाँ से गई तो ये एरो हो जाएगा इसका इस तरह से. And now you can draw, because of the parallel condition of streamlines, you may draw this type of streamlines. Similarly you may draw. तो वो जो आया था साई का एक्सप्रेशन, कई बार हम समझ नहीं पाते हैं कि वो ड्रॉ कैसे होगा, लेकिन आप ऐसे उसको ड्रॉ कर सकते हो. अब ये यूनिफॉर्म फ्लो है, ये यूनिफॉर्म फ्लो है. ये जो स्ट्रीमलाइन है ये एक बाउंड्री की तरह काम करेगी क्योंकि इसको क्रॉस तो करा नहीं जा सकता. तो ये ड्रॉ हो गई, ऐसे ही यहाँ से ये ड्रॉ हो गई. तो ये आपका फ्लो हो गया. अब आप और इसमें कितनी भी ड्रॉ कर सकते हैं. ये आपका फ्लो पैटर्न आ गया इसमें. दिस इज द फ्लो पैटर्न. Now you can also find here velocity components or the magnitude of velocity, as I found dw dz. dw dz was minus u minus m upon z. You may solve it in terms of polar coordinate and you may find minus u plus iv is equal to, this is small u, minus u minus m upon r cos theta minus I sin theta. So comparing, you may find u is equal to capital U plus m upon r cos theta, v is equal to m upon r sin theta. So these are the velocity components. Similarly, you may find magnitude of velocity. Magnitude of velocity is dw dz, and this is u square plus v square. So you may solve it and find u square plus m square upon r square plus twice m upon r u cos theta and square root of it. This is the magnitude of velocity. Similarly, you may find the potential lines. You put phi is equal to constant and get the potential lines. And thus this article is completed. In the same way, you may be asked to find the flow pattern or the streamlines if there is a sink at some point, there is a uniform flow in x direction, or you may be asked if there is a uniform flow in y direction and there is a sink at some point. So according to the situation, you frame your complex potential. For that, you find what is phi, you find what is psi, you make w, and with the help of the w, you may find the stagnation point, the velocity components, the streamlines, the potential lines, and so on. So this is the all about it.